So for this problem, we are given a 98 Newton box, that is the weight, and it's moving down the ramp with a constant velocity. So this is implying that it is moving down in this direction. However, constant velocity is saying this is a first law problem. So let's go ahead and label the forces. We have a static friction that is going opposing the direction of motion. This is going down the ramp, therefore the friction is going up the ramp, it's opposing it. We have the normal force that is always perpendicular to the surface of the object, and then we have the weight that's going straight down. The weight is 98 newtons. The frictional force is not 0.2. What has been given is the coefficient of static friction. So don't put that on your diagram yet. We can start off easy by focusing on the y-axis. This box is not moving away from the ramp in an upward direction, it is not drilling itself into the ramp. The y-axis is balanced, it's equilibrium, it's first law. If I assume up is positive and down to be negative, we get normal minus the vertical component of the weight is equal to 0. But after doing some trigonometry, we find that that's the weight times the cosine of theta. And if we solve for the normal, we get this. Now, this 98 times cosine theta, this is got theta, right? That's a variable that we need to look for. We'll move this aside to use later. We now turn our attention to the x-axis. So this object is moving left and right on the x-axis. It's moving down the ramp with a constant velocity. I'm going to make this be positive, this direction be negative. It's not second law because it's not accelerating. The velocity is not changing. The horizontal component of the weight is 98 newtons times sine theta. And it's a static friction because it is first law. If we go ahead and solve for the static friction, we get this. However, we know that the static friction by definition is mu s times the normal. The normal, though, was defined to be 98 newtons times cosine theta. And mu s has been given, it's 0.2. And if we multiply 0.2 by the 98 newtons, we get 19.6 newtons. So let's do some interesting math here. I'm going to divide both sides by 98 newtons. Which gives me this. Now, you have to ask yourself and do some soul searching. I'm not going to tell you either way. But doesn't the 0.2 sound familiar? And is it just coincidence? Or is it the coefficient of friction? I'll let you figure that out. However, when we did this division, the newtons did cancel out. So we're left with 0.2. But that is not our final answer. Somehow we have to get this theta by itself, and I have it in two locations. I'm going to propose to you something very wild. I'm going to divide both sides by cosine theta. So this is what it looks like right now. And by definition, sine theta over cosine theta is tangent of theta. So now I'm down to one single theta. How do I get theta by itself? We do what's called the inverse trig function. So in this case, it's inverse tangent. So I'm looking like this. And if I go ahead and put that in a calculator, making sure that I have my calculator in degree mode, I'm going to get 11.31 degrees if I round to the nearest tenths. So this angle right here is going to be 11.31, which would also be this angle right here.